All right, great to see everyone. And I know it's the last session of the day, so I super appreciate everyone coming. I know it's been a long track, so all I can promise is this is not going to be a boring chat. You're not going to learn about digital transformation and 7 tips to use AlphaSense. I don't personally know how to use AlphaSense, but I know it's a great product. I just flew in here from the Bay Area. I thought I'd give you guys just a kind of snapshot of where the state of the AI industry is and how we ended up working with AlphaSense to build a great product, and how maybe that can benefit you as well. So I was told to make a set of slides that is not appealing to just developers, which is my typical track. So these are kind of new, and we'll see how they go. OK, so this is just a brief outline so you know what you signed up for, right? AI models are flourishing right now. It's no longer just OpenAI. For a long time, it just was. AI hardware is also broadening. It's no longer just NVIDIA, if you can believe it. And as a result, AI builders and enterprises buying AI have a lot more choices, way more choices than they ever had before. And that's kind of what brought AlphaSense and Cerebras together. AlphaSense wanted to do things that wasn't possible with cookie-cutter solutions from OpenAI and Anthropic, and they wanted to run things much faster than it was possible anywhere else. And we were making some waves, using these open models and running them much faster. And we kicked off a very fruitful relationship starting the beginning of this year. And the result is astoundingly clear. It's these models that give you much smarter answers. They're much faster. They give these responses, a fraction of the time that you're used to from ChatGPT. And they're lower cost, too. So it's really almost too good to be true. And you should hold me up to that and see if there's a catch. OK, so this is a broad overview of how AI models have progressed since the birth of kind of the modern generative AI era. Everybody probably knows ChatGPT. That was the moment. I remember the moment that came out in November 2022. I was in New York. I was working in a restaurant in Brooklyn, actually, just for fun. And I'm like, I don't know what to do with my life. And then that thing came out. I'm like, OK, I have to move back to the Bay Area. I have to get a job in AI. It's extremely clear. What's really special about that time is you can see how singular that event was. GPT 3.5 powers the first version of ChatGPT. When it came out, there was nothing like it. It was the only piece of software in the world that you could converse with in a coherent manner, right? That was the magic moment. There's nothing like that before. And consequentially, there were no competitors. It was literally the only game in town, and OpenAI built an incredible business off that. Thankfully, the fundamental technology behind that is not an entire secret. It's based on transformers, this kind of style of AI architecture. And various companies have since then built similar products. But you will note that in the beginning, the gap between the colored lines from other companies and OpenAI were tremendous, right? The best free or open weight model, or alternative model, is like 18 months behind OpenAI. And there's a real question in the industry at the time, is anyone really ever going to be able to catch up? And thankfully, we have the answer now. Meta was one of the first companies to do something very radical. They released an open weight model, or an open source model. These words sometimes interchangeable, which means basically they trained the model, very expensive training run on their GPU cluster. And once the model is trained, AKA it can answer questions, they take that entire file and just put it on Hugging Face, and anyone can download it and use it for free using an Apache 2.0 license, right? This was radical. This is like, imagine Microsoft back in the day. Imagine if some other company replicated all of Windows and then just put it on the internet as like, here's a free version you can use. So it was a radical movement. But every time you have an open movement, you kind of spawn a huge amount of innovation. And from that, any company, AlphaSense, a financial services company, oil and gas company, can just download these weights and run them on their own data centers without using OpenAI. So all these lines since then represent kind of all the other companies that have tried to build smarter models, a lot of them open alternatives to GPT-5. The main thing is GPT-5, OpenAI has done a great job. It is still number one, but the gap has closed significantly, right? So how good are these open models that seem almost too good to be true? It used to be they weren't very good. Llama 70B was competitive, but it was not on par with the GPT-4 at the time. But the gap has closed tremendously. So black is closed source models, and you have a few flagship labs like OpenAI with GPT-5, Claude, Anthropic, Grok from Elon Musk. All those are very good, and they're still top 5, arguably. But the open models are kind of neck and neck, right? You have Alibaba and Meta, and of course DeepSeek, huge moment, January of this year, producing models that are, for most people, almost indistinguishable. Like if you had to solve an Olympiad math problem, you should use GPT-5. But if you're building a customer service bot, these models are completely good enough, way, way more than good enough, and you couldn't tell the difference. So open models have caught up significantly. And these open models have these great properties, right? They're open, so you can just download them, whatever. You can fine-tune them with your own data. So if AlphaSummit has all these huge repositories of expert calls and transcripts, and you want the model to really understand the financial services world better or the oil and gas industry better, you can pile your data in and train the models, and it becomes expert at your data. This is not possible with OpenAI, because they're training a model that's good for everyone. You can alter the model behavior. Maybe you don't like the way it responds in a certain way. Maybe it always says what you want it to say, and you don't like that. You can literally change its model behavior. Of course, you can also deploy it in your own data center, which is a very, very important requirement for enterprises with security requirements. And it's lower cost. I mean, OpenAI is a $500 billion company, not because it's a charity, but because it's making good margins on these things. And if you deploy it yourself, you can reclaim those margins. Okay, so that's the software side. It's flourishing. On the hardware side, it is also flourishing. It used to be that NVIDIA was the only game in town, and they have built an incredible business serving this AI demand over the years. But Silicon Valley never sleeps. It's like, if NVIDIA is making 80% margin, surely we can take some of that margin. And the result is it's funded all these competitors. And all these entrenched companies like Intel, Amazon have also funded their internal efforts. So there is more competition than ever than NVIDIA. This is a great chart from artificial analysis, and it serves both training and inference. But you would know that inference is served by almost everyone. It is the much larger market. And in case you forgot the first slide already, I represent this logo, Cerebras. Okay, so I know what you're thinking. You're thinking, okay, it's wonderful we have all these competitors, but let's be real for a second. Surely NVIDIA is still the best. It's a $4 trillion company. It has CUDA, right? No one else has CUDA. And you can't get fired by buying NVIDIA. And that is the perception. That is definitely the perception. But I would wager that the reality is a little different, which is that most enterprises building with AI don't even know what chip they are using, right? They're not choosing NVIDIA. This is not 1990 where we're choosing Intel Inside. There is no conscious choice. And that might seem like a pretty bold claim, but let me walk you through why that's true. Let's consider Anthropic. It is, along with OpenAI, the 2 leading AI labs in the world. It has the #1 market share in enterprise AI, ahead of OpenAI, right? It has #1 market share. It has $5 billion revenue run rate, $180 billion valuation. It is trusted by the Fortune 500 through and through. If you want a steerable, safe, dependable AI, you're going to use Anthropic, right? This is as enterprise as it gets, right? So what happens? Well, let's say you're a company, maybe you're Walmart, and you've implemented Claude as a service agent, and your customers are asking Claude about late deliveries. When the customer asks Claude a question, which AI chip do you think is used to generate the answer, right? Knowing that NVIDIA is the best. Is it NVIDIA? Is it a Google TPU, which Google's own chip in their cloud? Or is it an Amazon Trainium chip, which is Amazon's own chip, and Anthropic has a very close relationship with Amazon? Which of these do you think it is? Does anyone want to wager a guess? You don't want to wager a guess, because the answer is all of the above. Anthropic is very thoughtful. They have triple redundant hardware distribution. They have integrated their software to work with all of these chips. They have a very sophisticated router in the front end. And depending on the traffic, they will send your questions to 3 of these infrastructure backends. the customer cannot tell the difference. AKA, it doesn't matter. The difference is not so great that it even matters. If only NVIDIA could do this, this wouldn't be possible. So the reality of the AI landscape today is that developers used to program for very specific chips, like NVIDIA, Intel, we're very familiar with that era. But now they just write these APIs, which are these short little web requests to OpenAI or Anthropic. They're just passing messages between them. And that means the hardware is abstracted away and is invisible, right? This is a very new regime now. It's no longer the kind of vendor lock-in regime that is of some past eras. So this brings up to, I guess, what I'm here to talk about and what we've built. So given that hardware is democratic and it's invisible, anyone with a web programming ability can tap into a model that's been trained with billions of dollars. What do? At Cerebras, we're a company based in Sunnyvale. We started about 2016. We just raised a round last month, $8 billion valuation, and we built kind of a very unique AI chip. It's called a wafer scale engine. It's the only chip of its kind because normally when you hold a computer chip, you hold it like this. When we hold our computer chip, we have to hold it with 2 hands. So I call it a chest scale AI chip. It is rather large. And if you compare it to NVIDIA's flagship, the B200 that they're selling right now, it's almost comical how big the difference is. And when we came out with this in 2019, we're the only company in the world that could manufacture and commercialize a chip of this sort. And we thought maybe there would be competition, but in the 6 years since, this technical feat, which we worked with TSMC on, has not been replicated. We are still the only company in the world that can do this and that has commercialized this chip. Now, what good is a really, really large chip? It's really, really great for LLMs. So this is an example of answering a question. Let's say you're going to Tokyo, you're a vegetarian, you want an itinerary. On the left, we are done. We print entire pages at once of answers, right? The whole model weight resides on that chip, and the GPU takes a line by line, and you've experienced it. Every time you use ChatGPT, it's that experience. So it is almost silly, right? You go back and you're like, what do you do with a chip like this? You download the model weights from Meta, or in the case of AlphaSense, if they fine-tune a model with us, with all their special data, we put it directly on this chip. There's no memory external to this, and we just run it natively on the chip. And as a result, it's pretty much instantaneous, right? You almost miss it if you don't look at it carefully. It's just entire pages scrolling. So that's a pretty neat outcome for a radical semiconductor breakthrough. If you want some intuition for why it's fast, this is just a few slides to kind of go through that intuition. So on a conventional processor, before you build these absurdly large chips, when you want to run these models are about 30 gigabytes, 100 gigabytes, something like that. Something like something you buy in a USB stick. That's pretty large, though. The amount of memory, though, on a computer chip, like a GPU, is much smaller. It's a few hundred megabytes. So gigabytes bigger than megabytes, right? As I keep telling my mother. It doesn't fit. You can't put all that on a regular old computer chip. So what did the GPU evolve to? The GPU evolved into a 2-chip architecture. You have separate memory that's called HBM, and then you have on-chip memory that stores the thing you want to calculate, and you put some wires in between called a memory bus, and you just transport these weights back and forth to calculate the answers. That's why it comes out line at a time. If you imagine the model weights streaming across this wire, you're probably streaming across one line at a time, right? That's why it's slow. And what we did was basically say, hey, these models are too big. So let's do our best and make the biggest chip possible that ASML's machinery can even manufacture, right? We make this giant chip. We store the entire model weights, aka all the relevant bits to calculate your answers, onto the chip, right? So we take the whole model weights, we put them on the computer chip, not the memory chip. Next to it, we'll lay down a lot of compute as well. So the weights themselves are no good if you don't calculate stuff. So we lay down a ton of memory, we lay down a ton of compute, and then we connect them with these high bandwidth wires. The wires on a computer chip are much thinner than the wires outside, so that they can be much smaller, which means you can clock them higher, which means they're basically about 1,000 times faster. And the result is more or less infinite bandwidth. When you have infinite bandwidth, you can shuffle these weights back and forth almost instantaneously. So the result is this is kind of the AI landscape before Cerebras came online. You have Llama from Meta, Quen from Alibaba, and OpenAI recently recommitted to their mission of doing open source models and released GPTs OSS. So this is the best speed you can get on GPUs, hardware without Cerebras. We come onto the scene, and this is literally what we do. It's kind of unbelievable. This kind of delta is never observed in the computer industry because no one is quite crazy enough to build a chip 50 times larger than what came before. So these are independent third-party results. The best way to believe it is just to experience it, like type in an answer and watch the answer scroll. But this is the net effect we've had in the industry, and we've had a huge surge of interest, especially with the recent launch of the OpenAI model, which US enterprises really prefer, as well as the Quen 3 coder model, which is a great coding model. So what can you do with all this speed? OK, 1,000 words per second sounds great, but I can only read at 50 words a second. What good is the speed? And when we launched this last year, honestly, we kind of struggled because we weren't sure what to do with the speed. We knew speed was good. Everyone wants faster internet. Everyone wants faster cars. But apparently, those things are easier to explain, and you don't have to convince anyone why you want to buy a Ferrari. But faster AI apparently was not self-evident. And we struggled a little bit to express that value proposition. But once again, OpenAI came to the rescue. They came out with a series of models called reasoning models that required you to think a lot more before you generate the answer. So you can solve more complex problems like coding problems and math problems. So AI as an application went from a 2-second response on GPU problem, which is, OK, slow but no big deal, to a 20-second problem. And now we're like, we really have our raison d'etre, right? We have a reason to exist. And coding more recently has become almost a gigantic AI vertical, maybe the largest single AI vertical of all. Developers is maybe the last industry on earth. They're sitting in front of their computers writing code by hand, and now they're generating code by the pages. And these things take a long time, and they want it to go as fast as possible. And of course, with AlphaSense, it's doing a lot of research. It's searching through millions of documents, synthesizing them, putting them together, giving you guys back the answers. And Cerebras comes on, and our whole point to exist is to slash these response times by roughly an order of 20. So plain old chat is now instant. Reasoning is 1 second, which is good as instant. Coding is like maybe you used to go for a coffee break. Now you pick up your coffee, you sip, the code is back. And deep research is now down to 1 minute. So across the board, every high-value AI application that has time constraints, or you want to generate higher quality answers because the default versions from OpenAI are not good enough, we slash those times by about 20x. So here's an example of what coding looks like with Cerebras. This is create me a solar system. And we tell the model to do this. The code comes back instantly. The solar system is spinning before you can even realize what has happened. And over there is Anthropic Claude vigorously, diligently writing code line by line. And the special thing about AI code gen is speed really matters because until this thing finishes generating the last line, the whole program doesn't work, right? The whole thing has to be done before you get any value. So the developer on the left is just already on to the next problem. And the developer on the right is still waiting on his computer. That's ridiculous, right? It's still going. And this is a true story. So the value proposition that we struggled initially to communicate has become quite abundant. And 48 seconds later, it has finished generating a solar system. Arguably, the sun looks a bit better, but that's up to you. So abundant value, right? It is incredible. So this is the kind of technology that is the basis of what we provide. We can give it to everyone, and some people are more motivated than others, and some people are more forward-leaning than others. And AlphaSense is pretty much one of the first to reach out and say, hey, we want to really make our deep research much smarter and much faster, right? So we started a collaboration in March of this year, and it's been great. This is kind of something that Chris at AlphaSense showed at our conference. When they turned on Cerebras, the side-by-side of before and after is extremely obvious. TikTok was a big topic at Q1 of this year, and on the left is a traditional solution. It's still thinking. On the right with Cerebras, it's looked through millions of documents maybe, and it's generated the answer pretty much instantly. The thing with speed is also, it's not just speed. If you have extra speed, you can use it to generate higher quality, right? If speed is not all you care about, you can convert the speed to quality. These are fungible attributes. Just like, if you finish your math exam 30 minutes early while the other people are still going through it, you can check your answers again. You can make sure it's good. You can rewrite your essay. Anyone who has extra time can get better results. So AlphaSense leveraged Cerebras not to just go faster, but to read more documents, right? When you're trying to make an informed financial decision, you want to read more documents, and so really it is not just making it faster, it's improving the quality and thinking behind the results. We have a ton of other customers taking advantage of this. Coding is just endlessly entertaining. Windsurf is the leading competitor to Cursor, recently got acquired, and when they turned on our coding agent, code just came out by the pageful, right? They couldn't even believe it. It was incredible. And Windsurf, we're working with them now on some next generation coding capabilities that I'd love to tell you about a little bit later. Companies that we had no idea existed turned to us. This is an Australian company that built a little robot to teach you how to learn new languages, and it figured a physical embodiment would really encourage you. But when you're trying to converse, you want low latency, right? You don't want a very laggy experience. It breaks the immersion.
Can you come up with a 30-second story? And this time, Alex travels to Beijing to become a Peking duck chef. And can you reply in Chinese?
I have changed the conversation mode to push to talk for multilingual abilities.
在旧金山，一位名叫亚历克斯的机器学习工程师厌倦了科技圈的单调生活。
Yeah, it's pretty cute. With traditional voice to text, there's some lag, and what we've done for them is really reduce that and also allow the model to think more in between, right? If you're just fast and you can't think, it's not very good. If you can think and talk at the same time, it's much better. Customer service is another area where we've had some success. OpenCall is a great company born out of YC to really use AI to automate these customer service requests. Because we're so fast, we cut the latency down for them by 90%, and as a result, customer satisfaction went up at 20% for them. Extremely clean conversions. And when we show people, like, why do you want to use Cerebras? I've never heard of your company. Shouldn't I use NVIDIA? Should I use OpenAI? It used to be pretty tough. It's like, okay, we have to explain our hardware, and you may want to have to program in our language. But because AI has moved to web programming, all those conversations have basically dissolved. And this is our simplest way to be like, why do you want to use us? Well, we're about as smart as Anthropic, and you sure are using Anthropic right now. We're about 30 times faster. So if you want to get your work done faster, make your team more productive, you want to pick us. And you might be interested in reducing costs, in which case we can cut your cost down by 90%. It is a pretty clean and easy narrative. And the traditional pushback of, like, this is a risky technical integration. Do I want to invest in this new company out of Silicon Valley? That has been severely just basically kind of swept away, because the fundamental interface that 90% of developers today who build on AI employ is a web API call. It is no more complicated than the line of code they write to send a text message to their customer to say their delivery is on time. It is a web API call. Anyone in the room can build this. Anyone who's building OpenAI, just replace that with Cerebras. It's just a different address. Pick a different model. A string of text that used to get sent to OpenAI gets sent to us. We send you back a string of text. You don't have to know a line of CUDA. You don't have to know anything about Python. You just stay in your wonderful life as a web developer. So as a result of this ease of adoption, we've built a great ecosystem over the span of just a single year. We have some great partners from Meta to AWS, AlphaSense. We're serving the leading AI company out of France, Mistral, and incredible ecosystem partners as well. And the model diversity, of course, includes all the open models. And the best part for me for this diagram is none of them have to know that they're even using Cerebras. We've built an extremely, arguably exotic piece of hardware. We're down at the bottom. They just see the results of pages of text and code scrolling through. They don't even have to know about us. And that makes it very easy for our business to serve the wider industry. So that's it. Cerebras, we've been around about 10 years. We have, as you know, a very easy way you can integrate with us. It's been very gratifying to build and help AlphaSense. And I think we'd love to help a lot of more people in the world as well. So yeah, thank you very much.
I think we have some time for a few questions. If anyone has a question, just raise your hand. Great. I see you.
So in addition to the investment research process, have you also explored use cases in the manufacturing sector and the self-driving sector? Because those two are very latency sensitive and they tend to edge to cloud offloading eventually for analysis. Has that been a segment for you to pursue as well?
Yeah, thanks for that. For self-driving, which is more well-known, there are two parts in the compute stack. One is the training stack. One is the inference stack in the car. The inference stack in the car is better off handed with a smaller chip because you want low power. We're designed for the data center. So for self-driving, I think we could potentially serve the training of the model portion. As you know, Tesla had a very ambitious effort to build a training computer called Dojo. It actually looked remarkably similar to Cerebras. It's a very large kind of circular thing with independent dies, but it didn't work out for them because it is very challenging. So I think in the future we could serve the self-driving training market, but presently we're focused on language models. But a lot of the driving models are now also LLM-based, so it makes it very compatible. For manufacturing, we would love to help. I think maybe if it's a robotic system and it is using, there are many pieces to manufacturing, but if it's using a transformer architecture, it's very easy for us to integrate and speed up those processes.
Great. Any other questions? Great.
How do you think about your ideal end customer for the hardware versus the use cases that you're building for? And in the use case world, how are you sort of interacting with them? Is it direct or through cloud providers?
I see. I think for us, the best endpoint to reach is for us to be in a hyperscale cloud like AWS, or to serve a foundation model builder like Anthropic directly. Those are goals for us. It's hard to do those things in a single time step because they need to want that, and they need to see market demand, and they need to see our ecosystem mature and our capacity grow. So the way I've always thought about it is the best way to get to those A-tier customers is to build broad-based demand first. And the easiest way to do that is actually just to serve our hardware through a cloud API. That way, the friction for anyone here to access our hardware is not this long procurement process and a few $1 million. It's $10 and a few lines of code. And once we have enough of that, AWS, it will be in their interest to come to us because, like, hey, we're in the business of vacuuming compute demand, and we see there's a lot of compute demand for your hardware. Can we buy some and put in our data centers? Like, that's a non-pitch sales cycle, which I'm sure our sales team would appreciate, right? So the strategy is effectively build broad-based demand, build trust with enterprise like AlphaSense, and over time, I think we can have those productive conversations.
Great.
Hi, great presentation. So 2 quick questions. One, you showed like Perplexity as one of your users. I use Perplexity Pro religiously, but I don't see Cerebras as one of the models or anything where I can choose Cerebras as an option. Is that something that you are working towards, or like how can I find it? And the second part is, there are a lot of AI infrastructure companies which are building the bare metal stacks like CoreWeave, Nebius, and stuff like that, and companies like that. Have you thought about integrating your Cerebras AI chips with those AI infrastructure players so that you can be front and center instead of them buying from NVIDIA or AMD?
Which of those companies are?
CoreWeave, Nebius.
Yes, okay. On the first question, yes, we were integrated with Perplexity beginning of this year. They are constantly evaluating different model providers and different kind of solutions. So in a given time, we may not be online for them, right? I think right now we're not online for them, but they've been a customer that we've serviced. On the infrastructure side, we would love to be part of CoreWeave and all the neo clouds, right? But I think the story is also the same for them. They want to see demand before they commit to a bunch of CapEx. NVIDIA clearly has justified that, right? And we are in the process of justifying that. So I think once we built up the organic demand and their customers are asking CoreWeave, do you have Cerebras? Then that conversation becomes a lot more natural.
Great. I think one more question I saw. Did someone have their hand up over here? Great.
What's the biggest misconception you deal with, like, in your day-to-day?
There are many. One is that because we have such a large chip, we must have terrible yields. And it's such a recurring question. I wrote a whole blog about how we solved that problem by building in redundancy. Despite having a very large chip, our yields are as good as some of the top CPU, GPUs in production right now. So yield, like I like to imagine if I were giving a rap song, it's like I got 99 problems and yield is not one of them. Like that's one big misconception. The other is that there must be some kind of trick or catch on the software front. NVIDIA has CUDA. You know, NVIDIA IR has done such a phenomenal job that I feel like everywhere I just see people echoing, but they have CUDA. And I'm like, yes, they have CUDA. And no one uses it. No web developer uses CUDA. CUDA is used by super smart people working in AI research inside of Meta or OpenAI, right? They need to use CUDA. But the reason why those companies have so much value is because they convert AI into this thing that needs ML research, PhDs in CUDA, and then convert it into a web API endpoint, such that any dummy can now use AI without knowing CUDA or anything else for that matter. So we are on the, thank God for that, right? We're on the other end of that API, and we can service all those requests. You don't need to know that we're a giant chip. Maybe it's like, I don't know, humans on the back end. It almost makes no difference, but we can give it to you 20 times faster than any GPU. Early on, I said on the Anthropic side, their customers couldn't perceive a difference what hardware is used on the back end. We have the distinction of being the only chip architecture in the world where you can feel the difference because the difference is stark, right? So that's one of the most gratifying things about working at Cerebras.